Welcome back to my channel. Thank you for joining me on another episode of PriMath Zoom. In this lesson, we will be exploring the right-angled triangle. So let's dive right in. Do you know the different types of triangles? Well, there are 6 different types of triangles. We have the equilateral triangle, where all 3 sides are equal in length. We have the acute triangle, where we only have acute angles. We have the isosceles triangle, where we have 2 sides of the same length and the other of a different length. We have the scalene triangle, where all the lengths have different measurements. We have the obtuse triangle, where at least one angle is an obtuse angle. And we have the right-angled triangle. Here, one of these angles measures 90 degrees. In this lesson, we will be focusing on the right-angled triangle. What do you know about the right-angled triangle? We know that, yes, one angle measures 90 degrees and is sometimes shown like this. So here is the triangle, and it's sometimes shown with a little square where the 90 degrees is. Right there. Even though this triangle is orientated differently, meaning it is in a different position, the angle does not change. So if you use your protractor to measure, you will realize that this angle here, represented with a small square, also measures 90 degrees. And here we have another right-angled triangle. And if you notice, this one kind of looks different. But if you measure at least one of these angles, one would measure 90 degrees. And that is called the right angle. There are 2 types of right-angled triangles. We have the scalene triangle, and we know a scalene triangle has 3 sides with 3 different lengths. Even though we have that, we still have an angle measuring 90 degrees. So this side is 3 centimeters, this side is 6 centimeters, and this side is 7 centimeters. All 3 sides have different measurements, but the angle represented by a small square still measures 90 degrees. We also have this isosceles triangle. And what do we know about the isosceles triangle? Yes, 2 of the sides have the same length, while the third side has a different length. So this side is 5 centimeters, and this side is 5 centimeters, and the third side is 6 centimeters. And even so, we still have an angle that measures 90 degrees. So let us try to check if these triangles are right-angled triangles. So first, we want to place our protractor on one of the straight lines. Let's try this one. So we'll place our protractor on this straight line, and then you can see that this line is at 90 degrees. So this triangle is a right-angled triangle, 90 degrees. Let us check the second one. So again, we're going to put our protractor on a straight line, right in the center here, on a straight line. Now 90 degrees is up here, but you would realize that the other side, this side here, is all the way over here. So no, this angle is less than 90 degrees. So this angle is not a right angle triangle. What we can do, we can put something like that to show that it's not a right angle triangle. But let's try another angle. So let us put our protractor right here on the line. This is our 90 degrees. Shows that this angle here is less than 90 degrees again. So here, this angle is also not 90 degrees. So let's try this other one. Okay, so we're putting our protractor on the line. And we're going to identify the 90 degrees mark. It's right here. And as you can see that this line is all the way over here. So we can say that this is less than 90 degrees also. So here in essence, we can call this an acute angle. All of them are less than 90 degrees. So this is not a right angled triangle. With our third triangle, let's check. So we're going to place our protractor down on one of the lines and right up to the center here. Here, let us identify our 90 degrees now. It's right here. But this angle is all the way over here, about there. So if you realize this angle is greater than 90 degrees, which makes it an obtuse angle because it is also less than 180 degrees. It is at 100, say 25 or 115 degrees. So here we can say that this angle is an obtuse angle, and we can do this to show that the angle is greater than or less than a right angle. Let's try another angle. So let's look at this one here. Let's turn it around like this. And we're going to place our protractor on the line and right up to the center here. Let's identify our 90 degrees, which is right here. You realize that this line is about here. So it's right here. So that means it is less than 90 degrees. It's not yet over to 90 degrees. So we can again make an arch to show that this is not a right angle. Let's use our other line. Here we are. From this side, we're going to count from this end. So let us put our protractor flat on the line, and then we're going to identify 90 degrees right here. And if you look, you'll realize that the line is over here. So it is a far away from 90 degrees. That means it is not a right angle triangle. In fact, it is less than a right angle triangle. So here we can say that of the three triangles, only one of these triangles has an angle that measures 90 degrees. Please like, share, and subscribe to this video. See you next time.